All right, so we're going to talk about trigonometry today. All right, we've been dealing with these triangles, right? If I give you this triangle and I want to find x, what have we been doing? We've been dropping a height, right? Okay, and we have this angle, 147 is 33 degrees. And what did we do next? We find the sine, right? Sine of 33 is h over 14. All right. All right. So, what did we do then? We can find h, right? We multiply both sides by 14. And all of a sudden I have h. And we know how to do this, right? So now I have the h. And this h was dropped. It had to be perpendicular to use SOHCAHTOA. And then we have another triangle on the other side where we have sine of 47, right, equals h over x. Now instead of finding the number this time, I'm going to use h as 14 sine 33. I'm not going to get a decimal at this point. So if I say sine of 47 is h over x, and I put in 14 sine 33, in your worksheets, I know a few of you followed the pattern. The pattern was this. Every time we had one of these triangles, it ended up being the leg times the sine of the angle divided by sine 47, the other angle, right? And it happened over and over and over. Because if I do this, does everybody agree that this is the, I can put a 1 under that sine 47, and I can cross multiply here. Now this is where I'm going to get a little weird on you guys. I want you to look what I'm going to divide by 14x on both sides. Does everybody agree I can, right? I can do anything I want as long as I do it to both sides. And what happens? The x's cancel, and the 14's cancel. All right? And I'm left with sine 47 over 14 equals sine 33 over x. And you're saying, well, Mr. Anderson, that didn't solve the problem. But I'm going to take this ratio all the way back to the top of the board. And I'm going to pull out the blue that I put in the board here. And I'm going to look at this triangle. I'm going to leave the 33. And I'm going to look at the triangle again. Sine of 47 is here, right? 14 is across from it. Sine of 33 is here. X is across from it. Every time we have a triangle, we can set the sine of the angle over the opposite leg and know that it's equal to the sine of any other angle and its opposite leg.
It's only with sine.
It's only with sine. This is called the law of sines. All right? We have just proven the law of sines. So when I have a triangle like this, I don't even need to drop the height that we've been dropping. I can remove the height, and I can say I have little c here, and I can delete that line. And I can say I have the sine of a, right? Capital A. And what's that going to be over? Little a, the leg. And that's going to equal what? Well, let's go around the triangle. Sine of b over b. And that is equal to sine of c over c. And we have just done law of sines. And so when we get these triangles, instead of dropping the height, we can do this. Now, does dropping a height work every time? Yes. Will it always work? Yes. Can you always solve it that way? Yes. So if you remember SOHCAHTOA and just know sine, cosine, and tangent very well, you can do that. There are many times that I, in industry, before I started teaching math, forgot law of sines. And I always dropped the height, and I was always able to find it. But I tell you what, when you have to do as many homework problems as I assign you, right? And if I pull up today's homework, and we just do a couple of these, okay? it says draw a triangle EPR there. Mark it with the given information. Write an equation that could be used to find the unknown value. Then find the value of the nearest 10. They don't even draw the triangle for you. They have gotten extremely lazy in the textbook. All right? So I'm just going to do 1, and then we'll call that, no, you can leave it out. We'll do 1, and here, we'll do 10. So it says draw a triangle EPR. Everybody. Not to scale, right? It's never going to be to scale. All right? Angle P is 45 degrees in 10. All right? Angle E is 63. All right? Leg P is 22. Find leg E. And we remember the little letter goes across. So again, what's the ratio going to be using law of sines this time?
Sine of big E.
Sine of big E, sine of 63, over?
Sine of little e. Or over little e.
Over little e, equals what? Sine of 45 over? 22. All right. So how do I solve this? I'm going to cross multiply. Is that okay with everybody? There's a couple ways to do it, but I'm going to cross multiply. And I'm going to divide by sine 45. Does somebody have a calculator going on this already? All right. So I got to take 22 times sine 63 to get the answer. Then divide by sine 45. 27.7. Can somebody confirm that?
Yeah.
And that's the answer. All right. And this is law of sine. All right.